In terms of space research, the James Webb Space Telescope stands head and shoulders above the competition through its incomprehensible design and origins. Webb is exploring the mysteries of our solar system, other planets orbiting other stars, and our place in the universe. A star 120 light-years away from Earth was the target of a recent experiment using the Webb telescope. Astronomers are still scratching their heads about the possibility of carbon-based molecules in the atmosphere of a planet that is thought to be in the water zone after the super telescope found evidence of them. This finding opens exciting new possibilities regarding potentially habitable worlds in the cosmos and gives a fascinating look at a planet that is completely different from anything in our solar system. Exoplanet K2-18b, which is 8.6 times Earth's mass, has been studied by NASA's James Webb Space Telescope, and carbon-bearing substances, including methane and carbon dioxide, have been discovered according to previous studies which Webb's findings support. K2-18b may be a Hycean exoplanet, meaning that its surface is covered by water and its atmosphere is rich in hydrogen. Our understanding of the system has been transformed since initial observations with NASA's Hubble Space Telescope shed light on the atmospheric features of this habitable zone exoplanet. Located in the habitable zone, K2-18b is 120 light-years away from Earth in the constellation Leo. It orbits K2-18, a cold dwarf star with no similar surrounding planets. Exoplanets like K2-18b, whose diameters fall between Earth's and Neptune's, are unique in our solar system. Astronomers are deeply divided over the characteristics of these sub-Neptunes because of how little is known about them and their atmospheres. Some scientists think that exoplanets in the Hycean region provide ideal circumstances for looking for signs of life. Therefore, the idea that K2-18b could be one of these worlds is intriguing. The lack of ammonia and the abundance of carbon dioxide and methane lend credence to the idea that K2-18b has a water ocean under its hydrogen-rich atmosphere. Dimethyl sulfide is a molecule that can only be produced by living things on Earth, and these first results from the Webb Space Telescope raise the prospect of its detection. Plant life in Earth's oceans is responsible for releasing the vast bulk of the dimethyl sulfide that enters our atmosphere. The inference of dimethyl sulfide on K2-18b, on the other hand, is weaker and needs further proof, according to a University of Cambridge scientist. Future Webb investigations should be able to confirm the presence of dimethyl sulfide at detectable amounts in K2-18b's atmosphere. Even though K2-18b has carbon-bearing molecules and is in the habitable zone, it does not mean the planet can support life. The planet has a radius 2.6 times that of Earth and is thought to have a massive core of high-pressure ice, like Neptune, but with a thinner atmosphere rich with hydrogen and an ocean surface. For Hycean worlds, vast bodies of water are anticipated, but it is also feasible that the water is too hot to sustain life or even exist in liquid form. We have obtained the most detailed spectrum of a habitable zone sub-Neptune to date, and this has allowed us to identify the molecules that exist in its atmosphere, commented Subhajit Sarkar of Cardiff University, who is involved in the research. Research into the propagation of light from K2-18b's parent star via the exoplanet's atmosphere allowed for this examination because it is a transiting exoplanet. K2-18b's luminosity dims as it moves past its home star. In 2015, NASA's K2 mission used this method to discover the exoplanet. During transits, a tiny fraction of the star's rays pass through the exoplanet's atmosphere and eventually reach space observatories like Webb. As light travels through an exoplanet's atmosphere, it leaves behind traces that scientists can use to gauge the atmospheric gas composition. The team is planning to do more research utilizing the mid-infrared instrument spectrograph of the telescope. They anticipate that these studies will confirm their findings and offer new information about K2-18b's climate. The discovery of life on a habitable exoplanet will revolutionize our perception of our role in the cosmos, according to Madhu Sudan. Water has been detected by the super telescope in other locations as well. Complex chemical compounds resembling smoke or haze were found in a faraway galaxy, by astronomers utilizing the James Webb Space Telescope. We have pushed back the former record for such detections by nearly an extra billion years, and this is the oldest known example of complex organic molecules in the cosmos identified by humans. The fact that these findings at the cosmos periphery are shaking up our cosmology is in many ways both exciting and unsettling. This groundbreaking finding alters our understanding of early galaxies. An early galaxy that originated around 10% of the universe's present age contains these components. Polycyclic aromatic hydrocarbons, which are carbon-based compounds, are present in smog, coal deposits, and oil on Earth. However, this discovery is of great importance. The molecules we found aren't simple things like water or carbon dioxide, says lead astronomer Justin Spilker. Huge, squishy molecules containing hundreds or even thousands of atoms are what we're referring to here. Even while our models indicate that the cosmos shouldn't have been able to produce such huge and complicated molecules so soon after the Big Bang, the fact that it did is truly astounding. Because our galaxy is so vast, the light that scientists have been able to detect started its journey just over 1.5 billion years after the Big Bang. We are living in a universe that is around 13.8 billion years old. Here we are seeing the primordial era of the universe's development. The catch, though, is this. Thanks to Webb, we've pushed back the previous record for such detections by approximately an additional billion years, allowing us to detect these complex organic molecules. What if, instead of looking just at the Big Bang, we could go much further back in time? Would we find more of these molecules then? Our cosmological model and scientific knowledge would be profoundly affected by that. Another crucial point. Earlier attempts to identify complex organic molecules in distant galaxies could only confirm the presence of the chemicals. Thanks to Webb's sensitivity, we can now make out finer details about the precise location of these molecules inside a galaxy. We don't yet know why the concentration of these chemicals is not uniform in SPT 041847, an early galaxy. Additionally, this finding provides more evidence that galaxies were forming throughout the early cosmos when a great deal was still believed to be happening. Fascinatingly, despite being only a tenth as old as our Milky Way, this galaxy was already as large and had produced as much carbon and oxygen as our own. The vastness and intricacy of the universe astonish us. As we venture forth into the unknown, equipped with information and a need for comprehension, we are getting closer to unraveling the mysteries of the stars. With each new discovery, a fresh light on the cosmos emerges, thanks to Webb's impressive performance. If you found this fascinating and want to keep exploring the universe with us, don't forget to subscribe to the channel and turn on notifications so you never miss a discovery.